You like Trump? Good girl. You like Biden? Alright, good evening. Yeah, so many people ask me about bias, and I'm going to try to explain it the best way I can. This is a one pill check. It may not be the best one to show, but this is the input transformer. It's the output transformer. So the input of your transistor is what you're trying to bias, and what I get out of it is it's keeping the input of the transistor on and don't let it shut off. During sideband, since you have no carrier, when you stop talking, it it don't have a carrier. So like AM, you would have a say a 1 watt carrier or 100 watt, whatever you're doing. Sideband don't have a carrier, so the amplifier would actually just shut off. It would just while you're not talking, but when you start talking, it would click click click, and here go click 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 click. And biasing, you can put a delay on it, but that's not keeping the transistor on. It would still put a shock on the transistor trying to turn it on every time. But the delay, I've talked on amps with delays and never had any trouble with them on sideband. Let's just put it like that. Okay, so when I talk about the input of the transistor, this would be the input, this would be the output. It don't have a transistor in it, but it's just for reference. Alright, you can do it so many different ways. You can do it with voltage regulators. You can do it all different kinds of ways. Very, very, very different ways. And that's all you're trying to do is break the voltage down to between half a volt, let's say 0.7 volts down to 0.1. It all depends on what you're doing, what the transistor likes. I think a HG, I try to keep it around 3.3 to 0.4 of a volt. So little less than half a volt. Well, you can achieve that in so many different ways, like I said, but you can use these kind of resistors here that you can actually put compound under and screw it to a piece of aluminum and keep it cool. Or you could use these. That's what I normally use, and these normally I put them on top of the transformer, but you could put them down the side, you could put them anywhere, but it's all preference what you want to do. But I got my power supply out, and I'm going to try to do this. It explains some of it. The other part of it, like the relay, that's all you do is take a relay and take a relay. They got this. Let's take a relay. This is your poles that these would be the your coil. So you could put ground to this side or ground to that side, and hot to this side or either hot to that side. So you put hot here, ground here, and this thing will close. You can put hot here and ground here, it'll close. It don't matter. It ain't polarized to what side does what. I don't know if you can hear it, but I'm putting the ground on that side and it's closing. You can put the ground on this side, it's closing. It's opening and closing. As I touch it, it's opening and closing. It's very simple. It ain't no polarization to that. It ain't no hot and ground to these two here. Alright, these legs here, like this leg and that leg is connected to each other. And then when you of course energize this and close it, this leg and that leg pulls together. You can check that, but it's just like a switch. When you got your regular relays that's running your amplifier, so that's the one running your amplifier. So that would be this one here. So if you take this other set of relays and you run nothing but this wire here and this wire here, you run this wire to here, this wire to here, this relay will work when you key the mic, and this relay will work when you key the mic. And then you want to do your power, which is coming to your power that's coming to this circuit, that's feeding this circuit. From that kind of relay. I can get more detailed into that. I can show you how to do that one day, but let's keep it into this. This is what this is a sandbar resistor, 10 watt, 10 ohm. You can use 12, 15, but when you start using that, you have to watch what diode you're using. Like this diode with that resistor, I like to use what I call the Fat Cat diode. This is where I found out about this one, the 1N5822. This is the diode that I use. And actually this power is going directly to ground. You going through with power. DC 14 volt is hooked up here, and it's going down directly to ground. And you catching a sample of that, which I would call a sample of that voltage here. And this is what is going to go to your input of your transistor. And let's just tack this here. Let's just tack that there right now. And I'll show you with 12 volts or 14.7 volts. Alright. So I'm going to hook the ground here. And this is running, the power is going to come in here. Let's take a Sharpie and draw. So the power is coming through this way, here, going down through here to ground. I don't know if you can see that drew on there, but it's just making and going straight to ground. But as that's going straight to ground, this is taking up the heat from that being on. You're getting your voltage right here. So let's turn this off for right now. Let's hook up the leads. Let's hook up a voltometer here. Need to get me another one of these, by the way. Let's hook up the voltmeter. Get this where it ain't no glare on it. The ground will go here, and I do check these from time to time to make sure that I ain't got a messed up resistor. I check these before they go in because I'd rather check this before it goes in than I would risk. Even though it says what it says on it, and this number says what it says, I'd rather know what this voltage is before it hits the input of that transistor and maybe too high and blows that transistor. This is a lot cheaper, taking a little bit more time than losing a transistor. Let me see if I can get these. This is the voltometer. It's 2 wires coming from it. So ground is here. hot it's here, and this is the height of the meter. It's going to tell you how many volts is here. This is the DC power going in. The power's going through here, going down through here, and going to ground. So ground's hooked up here. The ground from the meter is hooked up here. So this is ground. That's the DC ground. And we're reading the voltage on the other side of that diode bled through this resistor. Whatever's left over out of this resistor is not being shunted to ground. It's what you actually achieving right here. You understand what I'm saying? You throwing all your power to ground. But what's left over, you catching right here. And this is the power you use to the input of your bias of your transistor. So, turn this on. And it's showing 0.412 of a volt. 0.11. It will start getting hotter. The resistor will start breaking down. It's got some heat in it. The longer it's set there, the more heat it's going to build up. But inside an amplifier and everything, it gets cooled down by the fan and this, that, and the other. And you really don't want to talk on it too long. But it should settle off within about a minute's time around 0.3 volts. But like I said, see here, so down here, it's ground, you ain't gonna see anything there. But what's left over, like on this side of it, here's your 14 volts. 14.7, it's meters off a little bit. But, 14.5, alright? And like I said, whatever's left over, it's what you get in there. And it matters, like 14.7. So, and then when you key the radio down, it's going to pull more, and the voltage is going to drop inside the amp. So you'll start getting a little bit drop, normally about 3.8 volts. But that's that one. So if you don't like that voltage, you can change your resistor. I mean, yeah, diode. You can change your resistor. I'm going to just try different ones for the hell of it. This 1N5406. Let's see what voltage we get on this one. That block resistor's hot, so but you can do it, like I said, you can do it a different way. But this way is pretty mean and clean, and it's not very complicated. And like I said, right here you're only going to see what's left of it, not being shunted to ground pretty much. Alright, voltmeter hooked here. This would be the one that would go to the input of your transistor. And this is just ground, and this is your voltage going in your supply. You have 14.7 volts. Let's see how much volts we got on this 1N50, I think it's 5406. Let's see what we got on this. It should be 0.7 volts. But that resistor is still good and hot, but let's see what we get. So this is normally what I use on a Toshiba transistor. I like about 0.7 on it. So that's what you see on that one. Alright, and that's with the, like I said, 5406. And let's play around. This is still a 10 watt, 10 ohm. let's try a different, let's let this one cool down. Let's try a different one. This is a 1N5408. I forgot what this one actually, I'd say this one probably 8, 9, 8 or 9, closer to 1 volt. So ground from the meter there, ground from the power supply here, and then here is going to be your 14, 12 volt, whatever, 12 to 14 volt, whatever you're going to run. Alright, now, well, that one will work too for Toshiba's. You can use that one. Alright. You can play around with these and see what voltage you really, and what class you want to get into. Class A, Class B, C would be just grounded out. Let's try this diode here. This is a 30 amp diode that's for a, it's a greenhouse, no, not a greenhouse, solar panel diode. I just brought this, the big one, 30 amp, and I've actually pulled through it 60. But I'm just curious to see what I get out of it. Just for the hell of it. But this is pretty much you buy a circuit. Now you can add stuff to it, and I'll show you in a minute. Let's see what voltage I get on this. And that's 2 volts. Pretty good. Or 0.2 volts. I don't know, I say 2 volts sometimes, but 0.2 volts. And but you can get into it, and you can use voltage regulators to regulate the voltage that's actually going in here. But all these components are going to change, because you say you go in with 5 volts here. Let's do that. Let's go back with the circuit that I normally use. Let's try the this is a the first one that I used. The what was it, 5822? So let's set the power supply. So if you wanted to voltage regulate, let's say 5 volt. 5 volt going into it from your supply. Say you got a voltage regulator on this side of it, and you only putting 5 volts through there, which would make this run cooler, but it's going to change your it's going to change your current coming out here, so a little bit. So it's a little less. Let's crank it up. Now you gotta say, you're gonna get some lag or some drain back. Alright, so that's there. But like I said, if you drop it down, you'll see a little decrease. So you could actually drop it down to say 5 volt with a 10 ohm resistor and use the 5408 with say 5 volts, and the only thing hooked up to this end of it is the meter. The power supply's not hooked up to that side of it. Let's get this where you can see it. This is the volt ohm meter hooked up to this side, power supply to that side. Alright, let's check it with 5 volts on it. So at 5 volts, let's knock it on down. So at 5 volts for it, but I'm pretty sure when you do that, it put a load on it, it's going to pull down. You just got to play around with it, what you want. And I know you see a little bit more added to it when we do these. This is actually a 104. This is the same thing as like this. It's just what I call a torpedo 104. It's the same as this, but it's a torpedo, and of course I guess the voltage would be different. And we just take that, it ain't got no polarity, and we just take that, put that around it, wrap it, and this is just for filtering and just to make it look a little clean. We'll put that there. Put that there. And we'll take a cap. This one is kind of little, but I'm going to use it on there. And I have used them before. It's 50 volt, but only 4.7. I normally use this one, which is 50 volt, 47 microfarad. Let's just stick this one on here. So the ground side goes to the bandit side. You got a bandit side. So this diode is nothing but a gate. Let's take this diode, which you can see better. This diode is nothing but a gate. Voltage will flow this way, but not that way. It won't flow back this way. Or it'll let a little bit flow back. Like a Xena diode, it'll let some more flow back that way. But these don't let any back. At least it ain't supposed to. But you got a bad one. But this is like a gate, and the voltage is going this way. Where the band. The voltage, so the hot side can be hooked up here, and the ground side can be here, and it won't blow up. Let me show you what a diode would look like if it blew. Alright, this is a regular little diode, and like I said, if you put the hot side on this side, and the ground side, I don't know if this power supply is going to be enough to blow it because it's only 5 amp. This might take more than 5 amp. But as long as you got it hooked up the right way, you can take the power supply and nothing happens. That's DC positive here, DC negative there. and I'm running 27 volts in it. Alright, let's run the voltage back down, and let's say we didn't reverse the polarity. We didn't reverse the polarity of it. I don't know. Let me try a different diode. I don't know if that was going to blow it. Let's try a 4148. This kind of looks like a Xena, but it's not. Alright, let's get this stuff out of the way. So, with this way hooked up, the diode will be perfectly fine. Because it's hooked up the right way. The voltage is only going this way and it's not backing up, alright? Well, let's hook it up this way. Backwards. Alright, the voltage is being sent to ground. And let's see what happens. It's done smoked it. It didn't pop, but it's done burnt the resistor up. Smoke come off of it. Let's see if it'll burn off. It didn't, nothing violent happened, so. But now this diode is no good, and even though it's no good, you can't tell it, but it's open. This is a dead. Well, it's not even a dead short anymore. It's just open. Let's try this 4001. So hook the banded in, the hot to the banded in, which is to be the wrong way. Let's see if it pops. Well, this power supply ain't enough to pop it. It's putting 5 amps to it, but it ain't enough to pop it. But it's backwards. See, the diode will handle more than it says. But it's ain't enough power supply to blow it. But it's hooked up backwards. Yeah. She's hot. But it ain't enough to blow it. But a diode has a polarity. But we'll hook it up like that. And we'll put the filter on it. And the negative side. So this diode's, the voltage is going towards my fingers. The voltage is going this way. So the negative of the capacitor goes here. Let's do it with the bigger one where you can see it. This 104 has no polarity, so it don't matter. This cap, it does have a polarity, so it does matter. So you put the negative in there, because that's going to ground. And this is the hot side of it, and this is just filtering. No, I got that in there wrong. So you got to watch what you're doing. Okay. The ground goes towards the band on this one, like this. And then the positive goes to the negative on the diode. But then again, this is ground, because the power is going this way, so that's ground on this side and it's positive on this side. This is your little voltage that's going out, so that's all that is filtering that voltage that's on this side of the resistor. So like this. So this cap is now just filtering this voltage on this side of it, maybe a little bit on this side of the resistor, but mostly on this side. So when you hook this up now, power supply voltage goes in here, and this is just ground. Like I said, I normally check mine just to make sure when it goes in that I'm going to see the voltage that I see. So turn my voltmeter on. Ground will go to here, to where the ground's going to be hooked up. And this is the new hot. This is the voltage you're looking for to be your bias voltage. This is your new port. 14 volts here. Your new bias voltage here. Alright. So if it was hooked up backwards, that cap right there would have been gone pop now. So you know when they go. If something happens and you got the cap in backwards, it will pop that cap. So remember that. So that's the best I can explain it. Like I said, it's so many different ways you can do it. You can use, but everything you do is going to need a little bit of adjustment. Like I said, you could use block resistors. That resistor's hot. There's so many different ways you can do it. These resistors, they don't have any polarity on them. They're just a resistor. This one is this is 25 watt at 20 ohms. Alright. Let's see what it shows. Let's see what it shows. It's double the value, the resistance of the last resistor we just used for, say, is this one. This one's only 10 ohm. This one's 20. It'll handle more power, more heat. But let's put, so the power goes here. The ground goes here. The ground from here, now this is just for checking purposes. And now we're just going to see what the voltage is here. Our new bias voltage. So this is voltmeter on this side and power on this side. Alright, turn the power supply on and run the voltage up. So you get 3/6 of a volt. That's still pretty good, but you have to work it and see how much drag back you get. But see, this one don't get as hot, and it takes longer to get as hot. So they give you a little bit more talk time, but it takes a little bit more room too. So there you go. That's all it is you pretty much dead shorten, and then whatever's left over is what you get here, and this is going to be your bias voltage, and this is the one you got to be most critical about. What goes in here, like I said, you can put a voltage regulator system circuit on it to knock the voltage down. Let's go down to, like I said, I've been thinking about doing 5 volt, and it'll be less stress on the transit, the resistor, the diode. It won't build up quite as much heat, but you still got that at 5 volt. But like I said, I need to test it and see how much when the actual transistor drags it down. It will drag it down some. So that 3 volts is probably going to go down to about 2. 0.2 of a volt. That's 0.3 is going to be, see, at your point. 0, that's a third of a volt. So, I hope this helps somebody out. And I hope you understand what I'm doing. So this part, if I was going to put it in this amplifier here, this would go to ground. That would go to ground. I would get my 14 volts somewhere off the other relay. Let's say here. Let's say here. Well, so my relay is here, and I got it. When I key it up, it switches power from this leg to this leg, I think. I'd have to test that, but say from this leg to this leg. I think it would be the back leg. So you put 12 volts, your 14 volts here, and then here, either one of these, whatever side, you could pull, and it would, hell, let's do it. Input of the amplifier, which it has no transistor in it, but it'll still key. But it's going to be in, at least I think it will. Let's see, it's going to be the ground. Let's see. It's going to be the ground to that. Even though there's no transistor in here, it still should key. And let's go from power on relay. That's going to be the red wire. This is going to go here. Ground wire. This is going to be for the key up circuit. It's going to go here. Alligator clamps. Just sample purposes only. Let's see if I can get this on here. Of course not. Alright, got that there. Okay, 12 volt from transformer here. And let's say it goes to this leg here. And then when it keys, it transfers the power from this leg. And this goes here. Let's try this monstrosity. Alright. Power supply's on. Set the 12 volt. Turn the amplifier on. And let's see if we got any voltage here and it's referenced on the voltmeter. see what I got going on. Let's see if I got any power. Yes, I have power there. I have power there. Let's see if I should get power here when I key. No. Alright, let's change legs. Alright, that leg and this leg. Got shit falling off. Okay. Alright, that's my power there. So it goes from the center leg to the back leg. Alright, so I should see power here if I run this green wire here. So it's all it's doing is switching the power over from this leg of this from this leg here over to that leg when I key. So from this red lead over to that green lead, and then that green lead transfers it over to the bias part of that. So there's our bias voltage right there. So every time I key, there it is. So I'm just keying the mic and the transistor and that's open circuit. But that's all I'm doing. And see, you can check your bias voltage on an amp and that transistor's not even in there, and you ain't got to worry about turning the most precious part of your transistor out. I try to do that as much as I possibly can. Check a transistor before I even put check an amplifier, biased amplifier before I even put the transistors in. So I hope you picked up on something. Like I said, we can go through this again kind of slower, but so relay, extra relay, and this is going to be for the bias, and you got another side of the relay, you can run it to ground and make your sideband delay from this. That's a little bit other, but it's the hot in the ground going to the board. This is the power for it. Alright, like I said, you can simply attach to your relay, your primary relay for your amplifier, and let's hook that there to this relay. You take your primary relay, you take your power from it that comes on with the switch, and you go over to this one. Now, you can get into, you can put a switch in between that to power this relay, and you could switch the biasing off to it somewhat. But that's a whole nother thing. Once you get into this and you get to learning from it and understanding what it is, you will pick up more things. Alright, like I said, this other jumper is your 12 volt or your 14 volt. Let's turn this up to 14 volt. Let's say, I say 14.7 volts because that's what a normal coil puts out. Alright, so the middle set of legs on this relay here, which is a very good relay, is your main, that's your power source, or you could put it on the back. It don't matter. You can put it on there. It's just going to put those two legs together and you're going to come up with the power there. It's just a switch When you key it, it switches the power to this. Now this right now has no voltage on it. But when you key the mic, everything hooked up. Oh, no power. Alright. So your voltage goes right there. Alright, but this here is going to your circuit that we just built a while ago. You buy a circuit. And then this here is your voltmeter, and this is just going to tell you what voltage is left over here. And this would be going to the input of that the transistor. Alright, I'm going to key the mic. Everything's hooked up. And there's the bias voltage. You get it? Pretty simple. But it's so many different things. If you want to hook it up on a switch, turn your biasing on and off, put a delay on it. You have to you gotta crawl before you walk. So that is a different thing. I've run into some trouble trying to get the switch to run right without picking up feedback and stuff like that. There's a few things you got to do to keep it from feeding back or getting into the switch or this, that, and the other. But and like I said, every little thing makes a difference. So you could use different resistors to achieve different things. Like this is a 25 watt 15 ohm. This will work fine. That other one worked fine. But it's just all on what you like, all on what you think you can use. I hope this helped you in some way. Show what biasing does, and like if you want to put it for a 4-pil configuration, I usually take 2 resistors and set them end to end. I try to match them up to the numbers reading the same. And you could twist these, which I'm not going to do it, because I might want to use these independently later on. But let's say you're going to do a 4-pil section. You simply put your 2 together. So it's a 4-pil section. Alright, it's going to be a 4-pil section. It's going to sit on top of your things, or either you can put 2 of these. God, that would scare the hell out of somebody. Alright, let's come up with 2 diodes. And you know, put your 104s and everything on it. So, like I said, this has got to go to ground. The banded in to ground. You're just shunting your power to ground, and then you picking up what's left over through this resistor. What this resistor can't run to ground. It's pretty much a dead short circuit, and you just picking up what voltage is left over. If that makes any sense, that's the way I think about it. You getting the leftovers. As men, we ought to be used to that by now. There's plenty of leftovers out there. We get the scraps. So on this, the way this would be a 4-pil, so your power would go in here from your relay and everything. So your power would go in there, and this is going to be for one 2-pil section. This is going to be for the other 2-pil section. So this is going to be ground to power this copper board. And let's just run this ground over to here. From this one to this one, because this is supposed to be all grounded out. So that's your grounds. And this is your 12 volt, your 14 volt, whatever you want to call it. 14 volt there. So this is just ground, voltmeter ground to show you what you get on it. We're going to glare on it. And then what's left over, turn your power supply on. There's your voltage. So that's your voltage for your one transistor, your one 2-pin section, and this is for your other 2-pin section. And it's a little variance in the power because a little difference in the resistors and this, that, and the other. You can calibrate it, switch things around, and get it more spot on if you want. But yeah, those resistors get good hot because it's going to a dead ground, and this is the only thing that's taking that blunt of that heat. But like I said, you can minimize the heat on this by putting a voltage regulator circuit, but some of the voltage regulators won't handle enough power, and you have to put multiple ones on there. Like this one would take 2 of the little ones, and then yeah, that's a whole different can of worms. But like I said, you got fans blowing on them, cooling them down, different things. That all comes into play. But yeah, there you go. I hope this helps y'all, and I hope this explains how you do it the best that I know how to show you. If I left out something you need to know, just comment in the box down there, and don't. Every time I say it, somebody does it, which it really is no stupid comments, because people learn at a different rate. But there you go. And if you think this is just a bullshit circuit, it's a lot of amps out there that pretty much use this circuit this way. The way they get the voltage going to it, for say as they're 14 volts and everything. Now that's this part of it here is pretty much the same way on a few amps that I've worked on, factory built amps. But the way they get the voltage to it, some of them get the power through the actual RF from the radio coming in. The voltage comes here. It converts the AC voltage into DC voltage, and it runs to this, and maybe a better way than using the relay. But the relay's less complicated for me in my mind, but I'm simple anyways. But the other way, like the X-Force way, works really good when it works. But I don't know. It looks like it could have its troubles too. Anything can have its troubles. So there you go. That's the best I can do with it. So you have a good day. Later.